morning to everyone. So today we'll discuss regarding nomenclature of coordination compounds, IUPAC rules. The full form of IUPAC rules is the International Union of Pure and Applied Chemistry. Okay, so how to write IUPAC name for coordination compounds. Okay, so generally in coordination compounds, so there is a metal and ligand, and this is N. N is nothing but what? Coordination number or ligand number. So they are present within the square brackets. So how to write IUPAC name for these coordination compounds? Okay. So there are some rules we discuss one by one. Okay. So first of all, the first one is the positive ion is named first, followed by the negative ion. So always we should write the positive ion name, then followed by the negative ion. Suppose I am writing an example as NaCl. Okay, NaCl. So first we called as sodium chloride. So in this, the sodium is a positive ion and the chloride ion is a negative ion. Okay, so we called as sodium chloride. In this, the positive ion is named first, followed by the negative ion. Same thing we are seeing in coordination compounds also. Suppose this is a coordination compound MLN. MLN. So in this, so what it is present in neutral. Suppose any X is present in before these coordination compounds, so this X comes under positive, so this overall comes under negative. Okay, suppose same thing if it is present like this MLNX, so in this what will happen? So this coordination comes under positive, this X will comes under negative. Okay na? So this is the first rule. So next we will go for the second rule. So while writing the name of the complex or coordination sphere, all the ligands are named in the alphabetic order. So we should always write in what? Alphabetic order, like this A, B, C, D. So we should mention in the alphabetical order only, irrespective of their charge. So irrespective. So what may be the charge? We don't know. So we do not require regarding the charge. Just we see we should write within the alphabetical order. So after writing the ligand name, followed by the central metal ion, so without a space, they do not contain any space with the metal and ligand, between the metal and ligand. Okay, suppose I'm writing like this. Suppose this is a MLN, so this is a coordination compound. So first we should write the ligand name. After writing the ligand name, you will write the metal name. So this is the second rule. So next we'll go for the third rule. So before going for the third rule, so we'll discuss the third rule later. Next we'll go for the another point. Okay. Mm. Mm. So this is a point, Amma. So in this point you observe, Amma, fourth point. So what is it's given here? You can see here. So in this, so what is it given here? See here. So generally there are how many ligands are there? Generally we already discussed. The ligands are totally three types: ligand, monodentate ligand, bidentate ligand, and polydentate ligand. You can also call as neutral ligand or negative ligand or positive ligand. Okay, so in this, if the ligands are negative ligands, always the negative ligands are end with O. It is always end with what? O. Then it will end with O. Suppose there are given fluoride O, F minus, it is a negative ligand. Next you can write chloride O, bromide O. So always end with O. Suppose hydride O. Okay, na? Always end with O. Okay. Suppose hydroxo. Okay. So oxo. Okay. So next thio. So these are all comes under negative ligands. So always the negative ligands is end with in O. Okay, so next we'll go for the neutral ligands. So neutral ligands have no special endings. The neutral ligands have no special endings. So for example, you take an NH3. NH3 is a neutral ligand. Why? Because it contains one lone pair of electron. It is a neutral ligand. So for this the name is amine. We called as amine. Suppose H2O we called as aqua. Suppose CO is a carbonyl. NO is a nitrosyl. Okay na? So these are all comes under neutral ligands. So the neutral ligands have no special endings. No special endings. Okay. Next we'll go for the positive ligand. The positive ligand always end with em. It is always end with em. The positive ligand always end with em. Suppose you take NH2 NH3 plus. So this is hydrogenium. Or you can take another example like this. NO plus is nitrosonium. Or we can take NO2 plus nitronium. So this always the positive ligand is end with em. Okay, I will once again I will repeat. Negative ligand is end with O. Neutral ligand no special ending. Positive ligand always end with em. The positive always end with em. Okay, so next we'll go for when there are several number of same ligands. Suppose several number of same ligands are there. Suppose you take HCl2, same ligand but number is 2. So the prefix should be written as, suppose it is 2, we called as dichlorido. Suppose 3 is present, we called as tri. Suppose if it is 4 is present, we called as tetra. Okay. Suppose 5 is present, we called as penta. Suppose 6 is present, generally we called as hexa. So this prefix prefix should be written if the same ligands are present in several number. In several number. Okay now. Suppose there is another rule also, when the name of the ligand includes a number. Suppose the name of the ligand is including a number like dipyridyl or ethylene diamine. Suppose ethylene En is nothing but ethylene diamine. So ethylene diamine, the structure of ethylene diamine is nothing but what? CH2, CH2. Next we'll call as NH2, NH2, ethylene diamine. So in this example, the name itself it containing what di is present. Yes or no? The name includes a number. It includes a number. If it is including a number, so what we should prefer prefix instead of writing diethylene. Suppose En is present in twice. Generally, we should not write as diethylene diamine. We should not write. So instead of writing di, the prefix should be used as bis. If 2 is present, we should write as bis. If 3 is present, we should write as tris. Suppose if it is 3 is present, we should write as tris. Okay na? Suppose if 4 is present, we write as tetra is. Okay na? So this is the prefix for the ligands including a number. The ligands including a number. Okay, so next we'll go for the another point. Okay, next we'll go for the other point. So generally the central ion in the positive complex ion or neutral complex ion has no special ending, but in the negative complex ion the name of the central ion end in 8. So in the in just we completed ligands. Next we are going for the metal. So in this metal what we are discussing here, so one thing we should remember, the metal ion, suppose if it is the metal ion MLN, suppose it is present in positive complex, or if it is present in neutral complex, no charge, either in the positive or neutral complex, what will happen? There is a no special ending. There is a no special ending. But if it is present in, suppose this MLN is present in negative, suppose it is present in negative complex, it is present in negative complex, so what will happen? Always the central ion is end as 8. It is end as 8. Okay, suppose I'm taking an example as in the presence of M, I'm taking as nickel. So in this nickel, what will happen here? The nickel is present in negative complex, so we'll write as nickelate. We'll write as nickelate. Okay na? So like this. So always the negative ligand is end, metal ion is end in 8. Okay, they're given an example like this, AgCN2 minus. Okay, so in this what will happen? The Ag is present in negative complex, that's why we write as argentate. Suppose it is present in positive or neutral, we'll write as silver. Just we'll write as silver. It is present in positive or neutral, positive or neutral complex. Okay, so next we'll go for the oxidation state. So while writing the oxidation state of the central line is shown by a Roman numerical. It always shown in the new like this. This is a Roman numerical 1, so this is 2, so this is 3. So always we should be writing no Roman numerical. So we should write, after writing the Roman numerical, so we should write in brackets. We should write in brackets. We should write in brackets immediately following its name without a space between the two. So after writing the ligand, next we'll write the metal. After writing the metal, we'll go for to write what? So we'll go for writing oxidation state. The oxidation state here we are writing, how we are writing? We are writing in Roman numerical number, Roman numerical, and we are writing in brackets. We are writing in brackets. See, you can see the example: titanium 3, copper 2. Okay, so next we'll go for the another slide. So next, so in this slide, so we'll discuss. So in this slide we discuss here um, for zero oxidation state. Suppose if it is a zero oxidation state, so how to write for zero oxidation state here? See, so generally 0 also written in 0, and we should write in brackets for 0. Okay na? Suppose for negative oxidation state, so how to write the negative oxidation state? Just to write the symbol and you write the Roman number like this for negative oxidation state. Okay na? For positive, just to write the like this. For neutral, for 0 you should write like this. For negative we are writing like this. Okay na? So this is regarding oxidation state. Okay, so next we'll go for the another point. Okay, so in this point, so what we are discussing here, so if the complex contain two or more metal atoms, if it contain two or more metal atoms, generally that complex we call as polynuclear. So there will be bridged ligands. What is mean by bridged ligands is nothing but what? If two metal complexes are there, so generally there is a bridge ligand. So in between there is a ligand like this. This is an X is a ligand. Okay, suppose you think this is metal, this is metal, so this is X. So X is nothing but what? Ligand. So in this what will happen? So this ligand so is joined with two metal atoms. So this ligand generally we call as a bridged ligand. So generally the bridge ligand which link the two metal atoms together, generally they are indicated by the with prefix mu. This is a prefix, we should use this prefix. Okay na? So next, if there are two or more bridged groups of the same kind, so this is indicated by like dimu. Okay na? Or trimu. Okay na? Generally if two or more, generally we should indicate like this. The bridging group bridges more than two metal atoms, so generally we can means more than, if it is bridging group it is more than two metal atoms is bridging, generally we can mention as mu3, mu4, like that. Okay na? So next we will go for some of the monodentate ligands may have more than one donor atom. Okay na? Suppose you can write, so you can take an example as NO2. NO can written as ONO also. Okay, so in this, which is a donor atom? And nitrogen is a donor atom to the central metal ion. In here, oxygen is a donor atom to the central metal ion. Yes or not? So what will happen? So in this, generally there comes under monodentate atom. Why? Because it donating only one electron pair. So some of the monodentate ligand may have more than one donor atom. So what will happen? Through which it can donate to the central metal ion. So this type of ligand generally we called as ampidentate ligand. Ampidentate ligand. So for this we are giving the name for NO2 as, we are giving the name NO2 as what? Nitro. We are giving the name for ONO as nitrito. So this is like nitrito. This is nothing but what? Nitro. Okay, so next there is also another example. Suppose MSCN, or we can also write like this, MNCS. Okay, now the first one comes out is nothing but what? Thio. S is a thio. This is thiocyanate. CN is a cyanate. Thiocyanate. So this is nothing but NC is nothing but isothiocyanate. Okay, na? So we can write this as thiocyanate S. This is we can write as thiocyanate thiocyanate N. Okay, na? So why? Because here sulfur is donating, we are writing as thiocyanate S. So if it is nitrogen is donating, we write as thiocyanate N. Okay, na? So such this type of ligands which may be bonded through different atoms are called, generally we call as ampidentate ligand. Okay, so next we will go for another point. Suppose for the complicated molecules, abbreviations are generally used. Suppose ethylene diamine, we no need to write completely ethylene diamine, just we can write as En. Again, so pyridine, just we can write as Py. So this is our abbreviations for the complicated molecules. Okay, suppose acetyl acetonate, we can write as ACAC. So this is nothing but what? Acetyl acetonate. Okay, generally we used so this type of abbreviations for complicated molecules. Okay, so next so this is some of the points how to write the IUPAC name for the coordination compounds. Next we'll go for discuss regarding how to write this one as this coordination complex. How to write this coordination complex? So there is a one rule, amma. So in this, okay, yep. So in this, while writing the formula of the complex, so how to write the formula of the complex? The complex ion, nothing but what? The coordination sphere should be enclosed in the square bracket. Always it should be included in what? Square bracket. It should be enclosed in square bracket. After enclosing in the square bracket, inside the square brackets, metal is written first. First we should write the metal. Okay, now after writing the metal first, then the coordination group ligand, then we'll go for the coordination group. The coordination group is nothing but what? Ligand. The ligand in the order, how the what is the order is, first we should write the negative ligand. Always you write the negative ligand, then followed by the, suppose negative ligand, followed by the what? Neutral ligand, and the followed by the positive ligand. Okay, na? Or alpha, and alphabetically according the first symbol within each group. Generally we should write in alphabetically according to the first symbol within each group. Suppose I'm writing, suppose you take in a metal like this, uh, copper. Here I'm writing as negative ligand first. Next I'm writing neutral ligand like this, NH3. So this is the representation. Suppose I'm taking an example like this. So this is metal, negative and neutral like that. Okay, na? So we should, this is the right while writing the formula of the complex, while writing the formula of the complex. So next, then how to write the charge? We should also know how to write the charge also. Okay, na? How to write the charge. Okay, so in this, so while writing the charge, how to write the charge here? See, So while writing the charge here, we can write like this. So this is complex M L N N. So in this, what we are writing, we are the charge where I should write the ionic on coordination sphere. Generally it is written in Arabic number followed by the sign. So first we should write like this 2 minus. First we should write the Arabic number followed by the sign. Okay. So suppose if it's present 1, we should write 1 minus. If it is present in 3, 3 plus, like that. So this is a representation. Okay. So next we'll go for some more examples regarding the IUPAC rules. We'll discuss example some IUPAC rules. Okay. So in this examples, the first we'll go for the first one. First we'll go for the first one. Okay. So in this you can see here you can see AG NH3 taken twice Cl. Okay, you can see, yes or not? So in this, so what is there here? AG NH3 taken twice Cl. So first we should write the ligand name. How many NH3 taken twice is there? 2. That's why I'm writing diamine. After that, AG is present within which sphere? It is suppose Cl minus AG plus. It is in positive sphere. That's why we write only silver. Next we'll go for what is a oxidation number. Generally oxidation number for Ag, X plus 2 into amine is 0 is equal to, here we can write as plus 1. Why? Because Cl minus automatically within plus 1. So X is equal to what? Plus 1. Okay, that's why I'm writing the plus 1 within the square brackets. Then after that we'll write chloride. So this is IUPAC name. So next we will go for the another example, CONH36Cl3. So first I am writing ligand hexamine. So next I am writing cobalt. Okay na? So next 3. So we'll get the 3. So generally we can write X plus 6 and amine is a neutral ligand is equal to Cl3. So we can write as Cl3 minus here plus 3. So automatically the oxidation state is plus 3. Okay. So that's why we write cobalt 3. Cobalt 3. So next we will go for, after writing cobalt 3, next you write here chloride. Cobalt 3 chloride. Okay. So next we'll go for the another example, COClNH3 5 2 plus. So in this, so first we write the ligand name. So first 5 pentamine. Pentamine. After according to alphabetic order, we are writing amine first. Pentamine. The next Cl is a chlorido. Next I am writing cobalt. So what is oxidation state is 3. How will get the 3? See, X plus minus 1. Chloride is a minus 1 plus 5 into 0. Amine is 0 is equal to plus 2. Why? Because here plus 2 charge there. So automatically we can write minus 1, it goes here. X is equal to plus 3. Okay. So that's why I'm writing pentamine chlorido cobalt 3 ion. Cobalt 3 ion. Okay. So this is regarding what IUPAC name for the coordination compounds. So thank you and all of you. So we'll stop the class.